All right, in the last video, we talked about the radius. In this video, we're going to talk about sine. So the sine is going to basically have to do with this side, or it could be this side. Just depends on where your angle is located. If your angle that you're trying to measure is here, and that's delta theta, where delta theta is equal to some initial, some final angle minus some initial angle. So your initial angle would be here, theta initial, and your final angle would be here. So that's what I mean when I say delta theta. So all of your angles are measured. Whenever you're going to measure an angle, it's going to be with two angles. So your reference is the 0 axis, or the positive x-axis. So instead of writing, well, what you'll see a lot of times is the following. Instead of writing delta theta, we just say, since theta initial is equal to 0 degrees, then we can just write delta theta is equal to theta final. And so we could always say, well, let's just let this be theta. So instead of writing the final, the little f all the time, we just write theta. So you'll see that a lot of times. So sine, when I say sine, I'm speaking of the sine function. So the sine function is as follows. If you know x and y, the sine function is just y over r, where r is the radius in this particular case. So this would be the side of interest, y. Now, I can say this a little bit better. I mean, when I want to say it a little bit better, so let me go ahead and do this. Let me again draw a circle. Okay. All right, so we have our circle here, and I can just go ahead and draw a straight line like so, and this is going to represent some point. And again, we just talked about this angle here, theta. And just in case you guys don't know what I'm saying this is T-H-E, this is Greek. Okay, this is the way, this is Greek, basically. So theta, it's T, you know, okay, enough of that. So I have R right here. We have 2 points. We have 0, 0, and we have X and Y. So we want to define this side, and let's just go ahead and define sine again. Sine of the angle under consideration, in this particular case it happens to be theta, equals to the magnitude of the opposite side over the hypotenuse. Okay? So it's basically the magnitude of the opposite side with respect to the angle. Now, what does that mean? You see how we have our angle here, and this is our opposite side with respect to that angle. So what I can do is I can just do this, and I can say this is over the magnitude of the hypotenuse side. Okay? So, I don't really like how this sine function is way up here, so I'm just going to move it down like so. All right, so this is basically our protocol for our particular triangle. Sine of theta is just going to be equal to y. That's our opposite side here. This is y. And this side is x. So this is y over r. And again, you guys know what r is. So let's just say that we have ourselves an x, y value of, again, we can use 3 and 4. So we know that r is just equal to 5 because of the 3, 4, 5 triangle. So, you know what, I'll just go ahead and work that one out again. Square root of 3 squared plus, how about I do this? This is just x squared plus y squared. All right. And so that means that r is going to be equal to the square root of 3 squared plus 4 squared. That's going to be 9 plus 16. And that's going to be the square root of 25. So we know that r is just equal to 5. And we know y. So now that we're there, we can just say that sine of theta is equal to 4 over 5. 4 over 5, and so we know what 4 over 5 is. 4 over 5 is just 4 divided by 5. And that's 0.8. 0.8. I'll just go back here. So the actual value here is 0.8. And you just leave it like that. Okay? That's it.